Hi everyone, welcome back to another episode. Thank you for joining us. And we have a very special guest with us today. Enikő Ladányi is a postdoctoral fellow at the Music Cognition Lab. She did her PhD at Budapest University of Technology and Economics, studying language development in children. She then studied early language-related skills in infants at the Paris Descartes University. In her current work at the Music Cognition Lab, she continues a similar line of research by exploring the relationship between rhythmic and language development in infants and children. Thank you so much for being here with us today.
Thank you for inviting me.
So tell us how you got interested in this field.
So both music and neuroscience came relatively recently to my research career. I did my PhD in typical and atypical language development and in children with developmental language disorder and typically developing children. Mm-hmm. And I was so lucky that by the end of my PhD, my supervisor told me that I can run a study in any topic I want to that's related to language development. And I was always interested in music. I played the cello, and music was always an important part of my life. I read some papers on the relationships between music and language, so I decided to run a study in this. And I looked into this literature, I read a lot about it, I designed the study and ran it. And I loved this area, so I decided that I want to do a postdoc in this topic. And that's how I got to the Music Cognition Lab, where I'm a postdoc now. And neuroscience came to my life in this lab because I was always interested in neuroscience too. I read a lot of papers with EEG, and I love these papers that investigated the neural background of language and rhythm processing, but I never ran an EEG study myself before coming to this lab. And in this lab, I had the opportunity to learn to run EEG with infants, with children, and with adults. So I'm very happy that I could add neuroscience to my research area here.
Yes, definitely. It's funny because most of the guests that we've had on have, either played the piano or the violin or something when they were a kid and all throughout their education. And it's interesting that when you have music integrated as a child, it sort of makes you interested in, studying it.
It seems to be quite general in the area. In our lab, I think everybody played musical instruments since they were a child.
Yeah, I bet. So your research involves, studying language, as I said in the introduction. So can you tell us what the relationship between language and music is?
So there are a lot of features that are shared between music and language, or music and spoken language, more specifically. Both are auditory stimuli, both have pitch differences and intensity differences and differences in duration. And maybe the role of these auditory cues is more obvious in music, but they also play a very important role in spoken language production and processing. So these auditory cues like pitch and intensity and duration and differences mark word stress, what is very important for infants for segmenting out the words from the continuous speech stream, and also for processing language as adults. And the prosody of the whole sentence is marked with these cues. So when adults process language, then these auditory cues help them to process the meaning and the structure, the grammatical structure of the sentence. Mm-hmm. And there are more abstract similarities too. So these are like more surface level similarities, but it was shown that the structure of music, the rhythmic structure and the harmonic or melody structure of music can be described with similar types of rules as the structure of language. So after all these similarities, it's probably not surprising that several studies show that music and language processing skills are related. So those people who are better at processing music are also better at processing language.
Hmm.
For instance, those children who are better at precisely tapping to music, they are better at repeating syntactically complex sentences.
Oh, interesting. That's so interesting. I hadn't thought about the similarities between language and music, but now that you state all of them, there are definitely quite a few. So you mentioned infants when you were giving that explanation. How can music inform our language ability when we are, 0 to 1 years old?
Yes, there, as I said now, several studies show that music and language skills are associated. These studies are primarily in children, and there are some in adults. And based on these similarities, we can hypothesize that maybe this association is already present in infants.
Mm.
So maybe those infants who are better at processing these auditory cues that are shared between music and language and the structures will be better at acquiring their mother tongue.
Okay.
And in one of our current studies, we are testing this hypothesis.
Oh,
We
wow.
are inviting 6 to 12 months old very young infants to our lab, and we are measuring their rhythm processing skills. So how can we measure an infant's rhythm processing skill?
Right.
We can't ask them to tap to the beat of the music.
Right.
So we do this with EEG. So we play a very simple rhythmic stimulus to them through headphones, and we are measuring their brain response. And from this recording, we can measure how well can they extract the beat from this simple rhythmic stimulus.
Sure.
And then we will invite back these infants to the lab when they will be not infants anymore, but children,
Right.
when they turn 4. And we will measure the associations between rhythm skills at infancy and language skills at age 4. And if they are associated, that will be that will suggest that probably these shared skills between music and language support language processing.
Sure. That has to be fun to get to work with babies so much. I feel like that would be what a fun, research participant.
It is, yeah, they are very cute.
I bet. So you've clearly done a lot of research and are very well informed on this topic. How do you think that the research that you've done and are doing can be practically used in a clinical setting?
So actually, one of the motivations for this study that we are running, I just told a little bit about, is its potential clinical relevance. Okay. Because maybe those infants who show poor rhythm processing skills at infancy will be the ones who end up developing some speech language disorders. Oh, okay. So we know that like acquiring our mother tongue is a very easy task for most of us. It's like not effortful at all, but for a smaller percentage of children, they are struggling with learning their mother tongue. Probably dyslexia is a language disorder that is more well known. So these children have primarily problems with reading, but there is another disorder, developmental language disorder, that is less well known, but it's also quite frequent. According to some data, 7% of children have this disorder. So these children have problems primarily with grammar. They can't produce very complex sentences and have problems with understanding them and make grammatical errors. And of course, these problems will lead to difficulties at school and also in their social life. So it's important to identify this disorder as early as possible and to give intervention to these children. But they are often not identified or identified too late. And our study could be a first step to try to identify risk for these disorders at infancy with a rhythm measure. Right. Because these skills are associated that maybe a short rhythm measure at infancy or very young or in very young children, or a combination of this measure with some other measures which show which children are at risk for developmental language disorder or other speech language disorders.
Sure.
And then speech language therapy or early intervention can start earlier for these children, and then they will have a better chance to have a good language outcome.
Well, that sounds like incredible work that you're doing, because of course with any, disorder, the earlier you catch it, the better. So that sounds like it would be very helpful and impactful.
Exactly. And yeah, I want to emphasize that a lot of work is needed until we can integrate this to clinical practice. But yeah, this is a good first step, and we will see what our results show and what future studies will show. And let's hope we can find some early identification tools.
Definitely. Well, you've already discussed so many exciting, findings in the research that you're conducting. But what do you think is the most exciting finding that you've observed in one of your studies?
I think I'm always the most excited about the most recent results I have. And we just got the paper accepted last week. So
wow.
At the moment, I'm the most excited about that.
Definitely.
So in that paper, we measured the effect of rhythmic stimulation on language processing or grammar processing. As children, we presented grammatically correct and grammatically incorrect sentences to children, and we asked them to decide if they are correct or incorrect. For instance, the bunny is eating is a correct sentence, and the bunny are eating is an incorrect sentence. So that was their task. And these sentences were presented in blocks. And before each block, they were presented either with a regular rhythm, so rhythm with a strong beat, or with a silence, with nothing, that was the control condition, or with a rhythm without a clear beat or structure. Okay. And we found that children perform better on this grammaticality judgment task after the rhythm with the regular beat. So that's another result that supports the hypothesis that rhythm and language processing are associated. So probably the same brain structures or partly overlapping brain structures are required for the processing of this regular beat and language. And by the regular beat, these brain mechanisms were activated. So it was easier to activate them for the processing of sentences. And that's why this difference appeared. And we tested if this is present in other areas too, like in non-grammatical or non-linguistic tasks, and it wasn't. So it seems that it's specific to language. And yeah, I'm excited about this because this is an interesting theoretical result about the relationship of rhythm and language, but it might also have a clinical relevance because, if future studies will also show that rhythmic stimulation or rhythmic priming, how we call it, has a positive effect on grammar processing, then maybe rhythmic priming could be integrated into traditional speech language therapy, and maybe the therapy will be more efficient with this.
Well, that sounds very exciting, and congratulations on that paper. That's really exciting.
Thank you.
Well, it was lovely having you here. Thank you so much for sharing your knowledge with us.
Thank you for inviting me. It was fun.